Well, thank you very much. Welcome to Advances in Research and Innovation stream of SNOMED CT Expo 2024. My name is Alejandro López Osornio, and I'm a Senior Implementation Specialist in SNOMED International. I will be moderating today's sessions. All questions will be answered at the conclusion of the presentation. Online attendees, please use the Q&A button to type your questions to the presenter. And on-site attendees, please use the microphone provided in the room. I'm pleased to introduce Tom Searle from the King's College of London and CogStack, who will be presenting multilingual support for systematic identification, linking, and contextualization of SNOMED CT terms from clinical narratives. Tom, please go ahead.
Thank you very much. That title, I realize, is a mouthful, so apologies for that. Good to be here today. Thank you very much. I will be talking through recent efforts that we've undertaken at King's College London and our NHS Trust sites, where we've deployed CogStack, of which I'm a co-founder and CEO of a recent spin-out, taking CogStack as a series of open source technologies to market predominantly across the NHS, but obviously internationally as well, as we look for kind of multilingual support. So this presentation is really a work in progress of what we're undertaking now and how we want to support the community in better adoption of SNOMED CT technologies for essentially structuring of unstructured data. So, agenda for today. I'll first be covering what is CogStack, and more in particular, what is MedCAT, or the Medical Concept Annotation Toolkit. You may have had a slight precursor in Studio 2 of AI Advances, and a colleague, Anthony Sheck, who presented there. If you didn't attend that, then no worries. I'll be actually reusing some of his slides. That were also some of mine, but that's fine. Progress so far in deploying this across numerous NHS Trust sites, predominantly on the research side. And then we'll also be talking about our plans ahead with UK English models initially, and then we'll go on to how we're extending support for non-English models, and then how we actually will grow and build these models in a systematic way. Yes. Okay, so to really scene set first, so 80% of healthcare data is unstructured. By unstructured data, I'm talking about the clinical notes that are typed in by healthcare professionals within the record. This really makes the data difficult to store, firstly. It's really difficult to standardize and integrate and ultimately deliver insights from. This really affects the whole kind of healthcare value chain, we can call it. So data managers face larger costs in actually even storing that data and having consistent systems or representations of that data. Operations teams face challenges in standardizing processes across different care pathways, specialisms. Finance teams can lose revenue, or the actual healthcare organization provider can lose revenue if they actually aren't essentially manually coding up correctly those sets of codes that are within that unstructured data. That as a function is obviously very difficult, can be difficult to hire for as well, because it's a specialist role, but then it's often under-resourced because obviously the main business of a healthcare provider is actually providing healthcare, not actually billing for it. Clinicians also don't get the full value from all the data that they type into these records. So they're busy away documenting what happened within the care pathway and then what the prognosis is and what the outcomes should be. But at the same time, we're not getting the kind of population health benefits potentially we could be getting from kind of analytical usage of all that data. So what does CogStack actually really want to do? We actually want to solve search, the problem of search for health data. So a little company called Google obviously solved search and the organization of the world's data on the internet. We want to do something similar for healthcare data. That's these disparate silo data sets that are spread across multiple data sources, often within healthcare settings. We're going to bring all that together and essentially put that golden search box into the hands of those that need it most. So all of those use cases or areas within that value chain that we just talked about, I want to give access to that healthcare data all in one consistent place. So we want to harmonize the data and standardize it and really make it searchable across numerous indices. We want to really importantly include live and historical data all in one place as well. What does this really look like after you've performed kind of generically an extract or an ETL or extract, transform, and load job is that you can search across healthcare records within seconds. So this is the MIMIC 3 data set. It's a US ICU data set that we've got 360,000 notes in there, and then you can just type something in the top, and then it appears within seconds. It works across anything actually within a text, not just the structured terms, so not just disorders, symptoms, medications, findings, whatever, but kind of anything you want to search. The issue there is obviously it doesn't contain any context. So when you search for diabetes, it also includes gestational diabetes, it includes history of diabetes, prognostic diabetes, diagnoses as well. So what do we do now? So this is where MedCAT, or the Medical Concept Annotation Toolkit, comes in. We teach AI to read the clinical text, and then we continually validate how these models are performing over time. And then we use clinicians that are actually either doing audits or doing some sort of research project to continually validate how that NLP is performing. We use a user interface called MedCAT Trainer, which then provides an ability to contextualize those terms as well. So we train further models to differentiate whether a given concept within the text that's picked out by the model is actually referenced to the patient itself. So the subject is the patient. We refer to whether it's happening hypothetically, or it's a negation, or whether it's happening in the past, present, or future. And these are further models that we train as part of the MedCAT model library. So what does that really mean? So it means within a set of notes, you can pull out all of the structure, or you can structure the unstructured data. And then you can re-ingest all that data the same way we ingested the unstructured records. And this, again, is MIMIC. We can search for diabetes, all the diabetes terms, and that gives, I think, 266,000 instances. I think there's 170 million different annotations, or MedCAT annotations, from the MIMIC 3 data. So we can share models between sites. Again, this is all still just one language, just in English right now. But really importantly, we did show, actually a couple of years ago, 3 years ago now, as part of some academic work, that we can share models between sites. So this is an initial model trained at King's College Hospital, a large hospital in southeast London. We shared that to another acute care trust, and importantly, a mental health trust, both in London. And they each only required 10% of the same training data, similarly newly collected training data, to validate the performance of and improve the performance of those models to 0.95 F1 for a select set of comorbidities. I think there's about 70 common comorbidities, including kind of diabetes, cardiovascular disease, and that kind of stuff. So that model is obviously specific to the clinical dialect of probably London. So there's obviously further work to distribute those models in elsewhere within the UK, and we're actually doing that right now. We've been doing that for the past year and a half. But also, how does this model compare to, obviously, non-London English, US English, Australian English, Singapore English, and also how does it compare to other languages, more importantly? So existing support of non-English clinical text. So the Dutch community have been an early adopter of CogStack and MedCAT tools for a couple of years, and this is a screen cap of a pull request for including our diacritics for the MedCAT library. So MedCAT is open source, so I do urge you to check it out. But this is I think, commit from 21, which included various characters that MedCAT can now support for Dutch. And they've gone ahead and trained their base model for to use Dutch, essentially, or to be available for Dutch. We've also had some early success with two providers in Thailand, and they've actually, so this was a surprise to me, having actually built this tool, that this actually worked. So there's mixed Thai and English script within the tool that correctly renders one and also correctly pulls out both Thai and English at the same time. So the way that model works was a slight mystery to me until I actually figured out that they've built their concept database, which we'll get onto what that means in a second, to support both English and Thai at the same time. So the reason why this actually works out of the box, which isn't that surprising if you think about it, is everything's in Unicode and text, so it should just work naturally out the box. And fortunately, it does. So we'll be continuing that collaboration with the Thai team as the work progresses. So we haven't actually built anything really specific so far. This is the slide I'm going to dwell on the most probably, for any specific language. We really tried to build tools and capabilities that allow folks to be able to take the open source essentially and then localize it for their own language and their own use case. So what does that really mean, and how can we, as the kind of core CogStack team, better support multiple languages within the technologies that we provide, such as SNOMED CT has done? So the main building blocks of a MedCAT, or kind of CogStack NLP model for this named entity recognition and linking task. There's three components to start off with, three kind of base components of knowledge you need to include. So you need a language corpus, a really generic language corpus actually, to train an embedding model. So an embedding model in natural language processing terms is a model that includes a dense semantic vector representation of the language itself and the meaning of the languages of specific words. So this could be a dynamic embedding such as BERT or any kind of large language model that includes the context of how words appear, or it could be static word embeddings as well, such as word2vec or glove. So that's your vocabulary. So essentially it's a table of word embeddings. So that's pretty simple. These concepts of vocabulary and concept database are specific to the MedCAT model. So starting now from the bottom left, so a source knowledge base. So we're in the SNOMED CT Expo, so we'll all be using SNOMED CT. For languages that don't have translations, obviously that can be difficult. So if there's another form of knowledge base you would want to use internally, that's also okay to then produce a MedCAT model from as well. As a core team, we're really relying on SNOMED CT to provide that kind of core existing clinical knowledge. We're very lucky in the kind of clinical field of having these pre-made knowledge bases available. We then really actually importantly include a fair amount of enrichment from UMLS, or the Unified Meta-Thesaurus for clinical language. That's really helpful, including a lot of synonymous terms that are available within UMLS, but not in SNOMED CT. This then forms essentially a very, very large dictionary that we call the concept database, and that's the thing we use for this in-context human-in-the-loop training from that previous slide where I showed the UI where you select what's correct and incorrect. That then forms the second part of the kind of MedCAT named entity recognition linking model. Really then importantly, we include a SPACY. So SPACY is a really common toolkit in the NLP community. There's loads of languages where they've already done conversions into kind of a sentence splitting, various translations for various language-specific idiosyncrasies within a given language. We use that for essentially tokenization and kind of sentence splitting and that kind of stuff. So that's really helpful. So if you don't have a translation in your language available in SPACY, then there is actually a guide online to create that as well. Those three things essentially form the basis of that named entity recognition and linking model. We can then form a MedCAT model pack, which is the inclusion of these top two boxes. So the MetaCAT models, which we've recently done a load of work on, or Shubham actually in the audience has done a lot of work on, including BERT-based implementations for these contextualization models. These can be included and trained. We've got various guides online to then do that. Again, that uses the output from that kind of training user interface that allows you to collect different annotations for those particular sets of tasks you want to train for. That is not language specific because it's again using Unicode and can really represent any language within that kind of UI. Relation extraction models as well. So this is a really interesting recent development that another guy, actually Vlad in the audience, has also worked on with Shubham. And so this is a really, again, it's a generic tool for annotating and picking out, extracting relations between different concepts within the text. So again, this is not language specific, so you can collect annotations for training those models. Again, it's BERT-based, which you can then package all together within a MedCAT model pack. This then provides essentially two calls for you to load up that model pack artifact. So it's in Python code at the bottom, so you've got two lines. You've got cat load model pack. The model pack path is just a file to a zip. And then cat multiprocessing allows you to perform extraction of the SNOMED CT terms, if that's the original source knowledge base you've hooked it up with, and obviously the vocabulary if you trained it with as well. The contextualization of those terms as well, using the MedCAT models, and then any relations between those terms as well. So what does this really mean? So new sites and project areas we've got coming up. We've predominantly focused on English so far. And a recent kind of EU-funded program, Data Tools for Heart, building cardiovascular tools, tools for cardiovascular research in particular. But they're really interested in building kind of core capabilities across these clinical sites spread all across Europe, the European Economic Area. So this includes areas that do have a SNOMED CT translation and areas that do not. So that's one challenge we're actually figuring out right now, is the kind of source knowledge base which is most appropriate for both the clinical site where they want to build that capability kind of using CogStack tools for that particular site and country, but then other sites say that Romania, for example, that don't have translations currently for SNOMED CT. So we've also got further efforts, and we're continuing the build out of collaborations in Australia, Thailand, and actually newly in Singapore. So we're really keen on ensuring that the core kind of capabilities and tools that we're building are appropriate for all those areas. So what does this really mean, and how do we build out kind of a continuous integration, continuous deployment model for multilingual model building? So to understand what we need to build, we need to know what's going to enact a change. And unfortunately, there's a lot of things that can enact a change. So a new SNOMED CT release that happens, thanks for the term ed, very frequently. We need to conduct a new release after a new SNOMED CT release, a new release from a spacey language model release if there's an idiosyncrasy or an improvement actually within the core parsing of the language itself. Then that spacey language model release may be updated, which we then want to re-include into our MedCAT model pack. A MedCAT code release, so we release pretty much every month the code, so we need some CI/CD architecture to pick that up and then rebuild and test all those models. And actually the core kind of environment where you're running all this stuff is you've got third-party dependencies as well as core Python versions as well. So a little screen cap from a recent GitHub action across all these different Python versions. We also have different versions of the MetaCAT and RelCAT code. That's also updating actually fairly frequently recently because of all the extra kind of improvements we've made. So to finish, so CogStack, we're founded and owned by these NHS trusts, but we're really keen on ensuring that we build tools for the wider community, and we obviously understand that the wider community isn't just in English. So we need to build tools that are appropriate for folks that are capable and willing to take on the work to be able to kind of localize set of tools that we're building, within our kind of home territory for their own as well. We spun out actually really recently, so this year, and we are in operation across these countries, but really hoping to be in operation in far more very soon. But we are fundamentally committed to open source as well. So yeah, do reach out. More than happy to collaborate on any projects and to improve our kind of multilingual support and outside of our kind of core territory, we should say.
Thank you very much, Tom. Tom now will take questions. As a reminder, if you're in the room, please use the microphone to ask your questions. Any questions? Okay. So I can ask you a question. So it's open source. So it's, the model itself is open source. I want to understand that. So is it a annotation tool or
yeah,
that's execute the model itself? Yes.
Yeah, that's a good question. So, this, oh man, that is happening. So the annotation tool is open source. The underlying library code, which runs that kind of extraction process as well as the contextualization process, and all of the code to be able to get that kind of source knowledge base into that model, that's all available open source. The model that is trained on those 4 NHS trusts that form our kind of founding consortium. That isn't open source because it's trained on kind of private NHS health data. So that's where, from a commercialization perspective, where we're kind of leveraging, we're kind of permitted to leverage that for kind of wider spread impact within the NHS. But obviously that model is not really relevant if it's English. So we're definitely committed to building out tools and helping the folks that are, trying to kind of utilize the same things that we've done in English in another language as the kind of Dutch and Thai team have done previously.
It's an amazing project. It's really nice. Really, really good. Thank you.
Thank you.
Any other questions? Okay. Oh, Stefan, yes.
When annotating clinical text with SNOMED concepts, of course, we always have different directions to go. For instance, try to annotate the longest span as possible and hope to find enough pre-coordinated concepts, or alternatively to annotate smaller spans. For instance, if you have diabetic retinopathy, there is a concept for diabetes mellitus and for retinopathy, but there's also, and you can have two annotations, but you may also take the whole span and annotate it with the pre-coordinated concept diabetic retinopathy or retinopathy due to diabetes. So what's your take here in this similar examples?
Yeah, it's a great question. So I kind of feel like you're a stooge because I have a poster actually talking about annotation concepts and different variability in synonyms in the hallway. So I'll be standing in front of one of the video screens. There's like 5, so I can't stand in front of all of them. But if you select the one that's my name on it, then I'll talk about that. So it's a really interesting point. So when you are annotating, we have, actually can't remember the details of the poster off the top of my head, but we've annotated, I think, around 100, this will go, please. So we've annotated about 170,000 instances of around 4,500 terms, I think it is. That's across a whole range of projects, from including kind of common comorbidities, into kind of very kind of bespoke ones, even terms that aren't even necessarily within SNOMED CT that we've helped kind of author, at least within MedCAT, that we then want to author into SNOMED CT in the future. We're going to pass that task over to the SNOMED CT authors within either Guy's or King's College Hospital. For the most part, we use pre-coordinated expressions, and then we do tell the clinicians who often aren't familiar with SNOMED CT to be as specific as possible within your kind of concept set. So if you are interested in annotating and getting the tool to extract diabetic retinopathy, and that term does exist, then annotate that term. We can see in our results of that poster that it really varies according to how that clinician has interpreted that guidance. So the clinician, again, we're all human here, they can go from annotating that kind of pre-coordinated expression, or they can annotate 2 different expressions even within different kind of annotation sessions, because they can forget what the guidance is, they can forget what they even previously agreed between themselves. So there's that continuous kind of checking process that we go through during that annotation process, that we try to maintain consistency. So if you want to kind of go the post-coordinated route, then that's fine as long as during the annotation you're consistently annotating that, and then the model can essentially annotate and perform that structuring consistently, rather than inconsistently collecting annotations, and then the model gets very confused about what's right and what's wrong. Because these gray boxes you see in this GIF, this is actually what the model predicts is within the text, and then it's up to the clinician, or the domain expert, I should say, to pick out what the correct or incorrect thing is that the model has done. They can also add extra terms in here as well, so if a term is missed off, then they can include those by right-clicking the screen. Great.
Thank you, Tom.
Brilliant. Thanks very much.
Great job.